Hello guys and welcome back to my channel, and today in this video we will be solving another important question on LeetCode, and today's problem is generate parentheses. So this is another classical problem of recursion or backtracking, and with the help of some simple approach we can easily solve this problem. So without wasting much time, let's jump into the problem. So the problem states that given an integer number n, we have to generate all combinations of well-balanced parentheses. So let's first understand the problem and then we will go into the solution. So let's now open our notebook and let's first understand the problem. So the problem states that given a number n, which can be any number, for example n can be 1, 2 or 3, we have to generate all the possible combinations of parentheses that can be formed given with that number. So let's see in detail that what it actually meant to say. So here you can see when the value of n is equal to 1, we are able to generate one of the parenthesis combination, that is an open bracket and the close bracket. Now when the value of n equal to 2, we can generate two sets of parenthesis combination. One is open close and another is open open close close. So here you can see all this output means all the combination of this parentheses are well balanced. Similarly, when the value of n equal to 3, then we can generate all this type of parenthesis combination. So I hope it is clear to you that what is the exact output that is this program actually needs. So let's now understand that how we can solve this problem. So just to give you a heads up, if you need the solution or the code of this program, the solution is given in the description below. But if you need to understand the concept, or if you want to get the intuition that how we will be solving this problem, then I will request you to stay till the end of this video so that it will be easy for you to understand this solution, and based on this understanding you can easily solve any problem in your future. So let's start solving this problem in the most simplest way. So here you can see the problem statement is quite simple and easy to understand. But obviously the code will be a bit tricky if you do not understand the concept. So before writing the code, let's first analyze and let's see how we can solve this problem. And based on these output that are given over here, let's see whether we can find any pattern to solve this problem. So here you can see when the value of n is equal to 1, our output is one open bracket and one close bracket. Similarly, when the value of n is 2, there are two open brackets and two closing brackets in both the output. Similarly, when the value of n is equal to 3, there are 3 open brackets and 3 closing brackets in all the output that are provided over here. So if you watch carefully, there is a pattern into this problem. Number 1 is like all the solutions that are given over here should be well balanced. Now let's see what are the other things that we can conclude from this above result. So here if you see, when the value of n is equal to 1, our output string is of 2 characters because it consists of one open brace as well as one closing brace. So for all the result you can see the total length of your output is double the value of n. So here you can see when the value of n is equal to 2, your output string is of 4 characters. Similarly here when the value of n is equal to 3, the length of the output is equal to 4 characters. Obviously this is a valid reason because all the parentheses are well balanced. So the output string should be double the input value. So let's make this point as one of the key point. So now since we have found out two of the prominent pattern in this problem, let's now see what can be the other key point from the solution. So if you look carefully at the solution, you can see that here in all the solution, the opening parenthesis comes before the closing parenthesis. So for example here, this is the opening followed by the closing parenthesis. Similarly here also, opening parenthesis comes first, then the corresponding closing bracket. Similarly, opening then closing. Here also if you look carefully, here is an opening, then another opening followed by a closing, which makes this as a complete parenthesis, followed by another closing parenthesis, which makes this as a complete parenthesis, then followed by opening and closing. So here you can see we got another key point, that is all the opening braces will be followed by the closing braces. Now since we have got all these important key points to solve this problem, let me tell you, we have already solved 20% of this solution. Let's now see how we can exactly solve this problem keeping all this key concept in mind. Now let me tell you one more thing. Whenever there is any problem during the interview, we tell you to generate all the possible combination of strings or anything, then blankly remember you have to solve with the process of recursion, because with the help of the recursion and with the help of the brute force algorithm which actually recursion follows, we can generate all the combinations of the string that our solution actually requires. But while generating all those combinations, we have to put some of the constraint or some of the boundary conditions so that we can get only those results that our solution actually requires. So let me tell you what I mean to say. Now since we have understood that we have to solve this problem using the process of recursion, let me help you in writing the code for recursion. I know recursion can be a bit tricky if you do not know the exact approach to solve the problem. But believe me, recursion is quite an easy one if you actually can draw the recursion tree of the problem. Because believe me, if you can draw a recursion tree, you can easily convert that recursion tree into code, and within a fraction of a second, you can easily solve the problem. So let's first see how we will solve this program with the help of recursion tree, and based on that recursion tree, how we will convert that into code. So let's first solve this problem. So here, as you have already seen, that we have concluded that the total output string will be of size 2n, which means n plus n, where the first n will be the number of opening braces and the next n will be the number of closing braces. So here, with the help of recursion, we have to generate all the strings with n number of opening bracket and n number of closing bracket. And also, since this combination should be balanced, so obviously this number of open braces should be equal to the number of closing braces. So think like that while we are generating all the combination of braces, if we can keep track of the total number of opening braces we have used, then also we can give that number of closing braces to make it a well-balanced tree. So let's first draw this recursion tree and let's simplify this problem. So here let's start, this is the root of our recursion tree, where the value of O, that is the opening parenthesis, is 0 and the value of closing parenthesis is also 0. And at the end of this recursion, our goal is we have to reach this value from 0 to n. Similarly, we have to reach this closing parenthesis from 0 to n. So this is our goal. Let's now see how we can draw this recursion tree. So on the first step of this solution, what we will be doing, based on this string that we can see over here, we will start our solution with our open braces. So here you can see in all the solution, the open braces is coming. So what we will be doing, we will start our solution with our open braces. And here, once we have given one of the open braces, right now the number of open braces that we are having in our solution is 1, and number of closing braces that we are having in this solution is still 0. I hope that is clear. Now let's go to the next step of our recursion tree. So here at this stage also, since the value of 1, that is the opening braces, is still not reached n, where n is equal to 3, we are allowed to put one more opening braces, because here we can go till the value of 3. So let's put one more opening braces over here. So our output should look something like this. So now the value of opening braces is 2 and the closing braces is 0. Similarly, for one more round, here you can see we will be going with one more opening braces, and here the value of opening braces is 3 and the closing braces is 0. Now at this stage, if you see, we do not have any opening braces left in our solution, means we do not have any pending opening braces left. So our recursion ends over here, means we cannot make opening braces count equal to 4 since the value of n is given as 3 over here. I hope this is clear. Now since we cannot give our opening braces over here, let's now give the closing braces for this output. So what we will do here, instead of giving our opening braces, we will be providing a closing braces. So here 3 opening braces will be followed by a closing braces. So here at this solution, the value of O is equal to 3, that is the opening braces we have 3 and the closing braces is equal to 1. Here again if you see, since we have already reached the value of O equal to 3, so obviously we cannot proceed further on the left side direction, means we cannot put our opening braces over here. So what we have to do, we have to give our closing braces. So here what we'll do, we will first give 3 opening braces followed by the 2 closing braces. So here the value of O equal to 3 and C is equal to 2. We have still 1 closing braces remaining. And since here the value of n is already 3, so obviously we cannot go to this solution and we will be providing a closing braces, and that is 3 opening braces followed by 3 closing braces. And here the value of opening braces equal to 3 and the closing braces is equal to 3. And at this point, both the opening and the closing braces is equal to 3. We are done with this iteration. Means our recursion ends over here, and this is our one of the solution. So here if you just go at the top, you can see we got our first solution, that is this one. See, this was quite easy. Now let's backtrack and let's see how we can solve the other strings over here. Believe me, this will be too easy for you if you can draw this recursion tree, and converting a recursion tree into a solution is a 2-minute job. So let's proceed with this backtracking. So since now we are done with this step, let's go upward. So here we will backtrack and here we'll see we are done with this step. Since we have already covered this 2, we'll go again upward. It's already covered with 2. Here we'll go upward. It is already covered by 2. Here we'll go again at this point. Here you can see we are only done with the left side and we have not drawn the right hand side. So let's put the right hand side. So as you know, on the right hand side, what we do? On the right hand side, we put the closing braces. So what we will do over here, we'll first give the 2 opening braces followed by 1 closing braces, because on the right side, we only put the closing braces. And here at this step, the number of opening braces is 2 and the closing braces is 1. Now here at this step, you can see one thing, that is, here since the value of O is equal to 2, means there is again a possibility of giving an opening braces over here. So what we will be doing, from here we will be again dividing the solution into 2 parts. When in one part we will be giving our opening braces and another part we will be giving a closing braces. So let's see. So here what we will do, here we will be giving 2 opening and then a closing braces as it is in the previous step, followed by our opening braces. And here the value of O will be 3 and the value of closing will be 1. Now at this step, since we are done with 3 of the opening braces, so obviously we cannot give any more opening braces on this line. So what we will do, we'll go on the right hand side and we will put the closing braces. So here our solution will be something like this. So here the value of O equal to 3 and the closing bracket C will be 2. Similarly, here you can see the closing bracket have not reached to the end. So we will be having one more step on the right hand side, and left hand side we cannot proceed further since we have already got opening braces to equal to 3. So we'll proceed to the right hand side and here we will be giving a closing braces. And here the value of O equal to 3 and the closing will be also equal to 3. And thus we have reached to another result, and that is this one. This is one of the solutions. So here you can see we have got another solution, and that is this one. See, it was quite easy to understand if you can draw this recursion tree. Similarly, in this way, here if you keep on drawing all the solution on each and every level, you will able to generate all this possible solution for this problem. I hope this is clear to you, and based on this approach only, we will solve this problem. So let's now convert this entire problem into code, the recursion code. which obviously seems quite tough because recursion seems to be a critical problem to understand if you do not know how to solve it. So let's see how we can convert this program into code. So here if you see, we will be writing a simple function. Let's name this function as generate. Within this generate function, obviously we have to send some parameters. So let's see what are the parameters that we have to send over here, means what are the parameters we have to keep on modifying. So the first thing that we need is the size, that is the value of the n. So we'll pass n as one of the argument of this function. Now if you see, on each and every step we are keeping a counter of the opening and the closing braces. So since we are converting this entire tree into code, so obviously in the code also we have to keep a counter of the opening and the closing bracket. So let's put an opening bracket and here let's put a closing bracket. These are nothing but a simple counter to understand that how many number of opening or closing bracket we have put into our solution. Now let's go into generating the parenthesis, that is dividing this entire thing into two parts, means generating this into a recursion. So here you can see on each and every step we are actually doing two steps. One is placing the opening braces and another is we are placing a closing braces. So this is open and this is close. Now one thing you have to note, we are placing these opening and closing braces based on the value of these parameters that we are passing over here. Means based on the value of the opening and the closing bracket we have, we are taking the decision that whether we can go to the left or we can go to the right. And when we are going to the left, our logic was we were seeing that whether the value of O is equal to n or not. Means till we have reached the value of n, we were blindly putting opening braces into our solution. We will do the same thing over here. So here what we will do, we'll put an if clause and we will check that whether this opening braces is less than n or not. And if it is less than n, then what we'll do, we will place our opening braces over here and we will pass this string into our next function call so that it can reach in the downside direction. So here you can see for this condition we have to place our opening braces. So what we will be doing, we will be calling this generate function recursively and here we will be passing number of opening braces, closing braces, as well as we will be attaching our opening braces into our final string. Means this is actually the resultant of our recursion. So here what we will do, we will create another variable called as string. So here you can see we are taking four parameters. One is the n is the total number of string. Similarly, we have an opening and closing counter which capture the total number of open and closing braces. Similarly, here we have a string which actually hold the value that we are generating, that is this resultant string. I hope this is clear until now. So we have completed this part of the program. Now let's see how we can move to the right hand side of the program. So the right hand side is also quite simple. So here if you see, whenever we are going on the right hand side, we are actually checking one condition, that is whenever the value of the closing parenthesis is less than the value of the opening parenthesis, then we are providing a closing parenthesis over here. So here the condition will be if the value of the closing parenthesis is less than the opening parenthesis, then here we will be providing a closing parenthesis. I hope this is clear. So here we have created both the left hand side of the recursion tree as well as we have generated the code for the right hand side of our recursion tree. So let's now generate the string for this one. So what we'll do, we will call the function called as generate and here similarly we will pass open, close and everything and then we will be closing this parenthesis over here. Now let me tell you one thing. Whenever you are actually opening or closing a particular parenthesis on a given string, if you see on the next step, we are actually incrementing the value of the opening or the closing braces. So here you can see when we were going on the left hand side, here we were incrementing the value of the counter of open from 2 to 3. Similarly for the closing also we are increasing the value of the counter from 1 to 2, from 2 to 3. which means that we are keeping a counter of total number of opening and closing braces that we have utilized in our solution. So what we will be doing here, when we are using our opening braces, we will increase the counter by 1. Means we have used one of the opening braces into our solution. Similarly, when we are closing this parenthesis, we will increase this closing parenthesis counter by 1. So I hope this is clear to you that how we have converted entire recursion tree into code, and I hope this is very easy for you to understand, and with the help of this approach you can solve any recursion problem in the future. And if you subscribe to my channel, I will post further contents on recursion, and with the help of those approaches you can easily understand that how to solve any problem with the help of the recursion. So do not forget to subscribe and hit the bell icon so that in the future you are always up to date with the latest interview question. So let's proceed further. So here you can see, since we have already completed generating all the possible string with the help of the opening and the closing braces, we are almost 90% done with the programming. Only thing that is left is like, since we are calling this function recursively, so there is no termination, or there will be an infinite loop that will be going over here. So we have to put a termination condition into this function so that we can stop this program. And to get the last condition, that is the end condition of any particular recursion, you have to see the leaf node of your recursion tree, that based on what condition we have terminated our program. So here if you see, this is one of our output and this is one of our output, and our ternary condition was the length of this opening or the closing braces should be equal to 2n, that is open plus close is equal to 2n. That is our ternary condition. So what you can do, you can simply write, if open plus close is equal to 2n, means we have reached the leaf node of our recursive tree. Similarly, one more approach is like, if the string that we are generating over here is equal to 2n, we can also end this program over there, which means that if the length of this string is equal to 2n, means we are done with the entire solution and we can close this program, means we will return from here. And that's it. This is the end of this complete recursion. Thus, we have solved our problem. So I hope it was quite easy for you to understand. Let's now run this code into the LeetCode and let's see whether it is running properly or not. So I have already written down the code in LeetCode using the Java language, and you can see this is exactly similar that we have explained over here. So here you can see we are creating a function called as generate, where we are passing a placeholder called as result, which will collect all the collection of this leaf node. That's why it is an array list, and followed by the value of n, that is the max till which a counter can reach, followed by the 0 as the opening parenthesis and 0 as the closing parenthesis. And similarly we are here passing an empty string, and here in the function we are checking first that if the value of open is less than maximum, means we have to give the opening parenthesis. So we are providing an opening parenthesis into our solution and we are incrementing by 1. Similarly, on the right hand side, we are checking that if the close is less than open, then we are providing a closing parenthesis and we are increasing the close counter by 1. And at the end, we are checking that whether the string that we are generating over here, if it is equal to 2n, then which means that we have got the result and we are storing that result into our array list, and that array list we are returning from here. So let's run this program. So here you can see this is accepted. Let's also submit this program, and here you can see this got accepted over here. And thus we are at the end of this problem. And if you have liked this video, do not forget to like this video, and if you are new to this channel, do not forget to subscribe to my channel and hit the bell icon so that you are always ready for your next interview. So we'll see you in our next video. Thank you.